Okay, hello everybody. This is going to be a quick introduction to SideWinder. I'm actually going to just start off by showing a demo application that I've started to write. It still needs a little work. You can see the buttons are a little off, but what I have here is deploy. It's something called SideWinder deploy, which is it's using the SideWinder framework that I put together, and the idea is that it's going to be used for. It's a sample application that's going to be used for deploying builds out to machines. And so anyway, this here that popped up. This is the an example client application, and then there's a back-end web server behind the scenes. The web server behind the scenes is used for reading and writing data to the database, and the client makes HTTP calls out to the web server for getting CRUD operations against the database essentially. So the first thing that happens here is basically the sign-in dialog. I'll do a quick sign in, and I am for sure messing this up. There we go. Hopefully. Okay, and you can see a little janky, but you can see it says welcome FileGuard. Here's the here's some lists of projects, environments, machines, and tenants. And this does a refresh from the server. So as I change the current active project to these sample ones, it's actually doing back-end requests to the server to get these details. So if I click refresh, it's hitting the server, and in the back end, it's actually hitting the database. So behind the scenes, let's say the project service. The project service lists projects, allows you to create projects, etc. And first of all, what we're looking at here is HAX code. So what is HAX? HAX is a cross-development toolkit. It's a language and then a set of tools for developing software for different platforms. So you can write HAX code and then target iOS, Android, browsers, Windows, Linux, Mac, all from the same code base. And so it looks like this. It's pretty easy to read. It looks very close to something like JavaScript or C# or Java. It has that style of syntax, and you can see there's a project service in this case, and that's what this is calling. Is if I go to projects, there's a list projects function. Here's this server side list projects where it actually goes to the database, generates a list, and returns it. And so as this guy here does that, it's making those calls in the back end. And the really neat thing here is that the client is developed in HAX, the server is developed in HAX. The client that you're seeing here is running on Windows as a essentially a native app. It's not running in a browser. It is a native application, and it can run in a browser, but this particular build right here that I'm looking at and that I'm debugging is running in what's called HashLink, which is it's one of the targets here. And HashLink is a special virtual machine that was written for HAX. That the virtual machine has implementations on Linux, Windows, and Mac, and therefore you can build one build and it'll run across all three of those platforms, which is really nice for writing desktop applications. And then I am using, in this particular case, highly recommended using HAX UI, which is a UI library that provides user interface controls. You can develop it once, so you can basically, this is the hacksui.org site. Shows an example of, let's say you want to have a drop down. right? You can declaratively define what everything looks like using an XML style syntax, and then write backend code that, or write the actual hacks code for dealing with it. Like if if you have a button and then you want to hook up a selected event, you would write the hacks code, and it automatically wires everything up. It's very nice. So what's happening in this particular example is that all of this was written using Hacks UI's controls, and it's making calls out to the web server. So first, let's show. Okay, this is the client. So I'll just give an example of, let's say, I'm going to click on the create project dialog. And the create project dialog is what happens when you click this button here, new, and it pops up a create project dialog. Behind the scenes of this, there's a create project dialog XML file, which defines the basic layout, and then there's also the actual create project dialog source code. So when I click click the create button, or the new button, sorry, the create button here, it's going to trigger this event. So the nice thing is that I'm running in Visual Studio right now. Set a breakpoint. Bang. I'm straight in here. I'm debugging. I'm stepping through. I can see the values of everything. The name is empty. The description is empty. So it's going to get to the validation phase, and crash, because I apparently didn't check for nulls in my create dialog. Yeah, you see, actually, very simple, right here. I'm going straight to the text, and I'm trying to trim it. So what I should do is be going, name field. Here's what I do now. Everything is AI. I could do this obviously, but I'm just going to type it. Fix null error in name field and desk field in do create function. Do it for me, AI. So I was just going to add null checks, right? If it's null, then it returns immediately saying, an error. Cool. All right, I'm going to stop that. It fixed it. I'm going to hit Shift. I'm going to hit F5. Reload. It's building. So one of the things I should also just say is that there's this is Visual Studio Code. There's a plugin for Visual Studio Code for hash link debugging. So there's hack support, a hash link debugger. These are the type of things that allow you to actually set these breakpoints. And there's also a Lime plugin, which is required here, that basically does, Lime is a layer on top of hacks that allows you, that gives you a whole bunch of tools and things that help make development easier. So basically Lime actually gives you this build system and this Visual Studio integration. So when I'm in the client, down here at the bottom, and I have Lime installed, I can actually say what my target is. So is my target HTML5, which means I'm writing something that's going to run in a browser. Is it Windows, in which case it actually will compile using C++ and Visual Studio Build to the MS Build functionality to build the actual application as a native application. When I'm debugging, I do everything in HashLink as a debugger, and that allows me to put breakpoints in the code and all that stuff, step through and see everything and make changes, and then I can switch out to a different type of build and just test it and make sure everything's still working. So I've launched this guy again. Let me sign in again. And you know, one of the things I've realized as I'm making this video is that making these videos is a lot more challenging than I originally thought. And so I'm not sure if I'm going to repeat myself here, but I'm going to show that this has this particular application has a SQLite database backend on the web server. Hack supports SQLite and MySQL natively. It's part of the framework. So basically I can actually go and in SQLite I could see I have a database with a bunch of tables already in it, and one of my tables is users table, and this is where all the data from this demo is actually coming from. So I've logged in here, and now I click create new, and I click create, and what the hell? All right, well, this is what debugging's for, right? Let's go over here and find out what's going on. So this is my call stack, create project dialog, if name field. Oh, you idiot, I didn't even see it. That's why you don't trust AI. AI is the worst. I'm just kidding, it's actually awesome, that was my fault. I know it looks super lazy. I'm actually trying to just show off the fact that AI works fine with hacks. It understands it. It has no problem. Half the stuff that I've written in here has just been allowing the AI to actually generate it for me, which is pretty cool. So I'm gonna rerun this again. I'm gonna set a breakpoint and do create. But the real goal of just showing this off was the fact that, okay, I'm writing client-side code, and in hacks I'm debugging it, and I can also write server-side code and debug it. So, which I'll show in a second, as soon as I get past this stupid error. All right, so if I go new, I'm not going to fill anything in. I'm going to hit create. You can see that this time it checks for nulls and handles it correctly. So here it's going to say name required, invalid characters, and name, whatever. So there's that, right? Now let's show something pretty cool here. So the next thing I'm going to do is I'm actually going to switch to HTML. So what I'm doing is I'm switching the target to HTML. I'm going to build again. It's Control-Shift-B. Just hit that. It'll do a build. It's building. So what it's doing in the background right now is it's actually building out a JavaScript file, and the way this project has been set up is that I have one repository with a client in it, and the client code is here, and the server code is here. And when I build for the HTML5 target, it does a build, and here's where the builds end up, right? So there's in the folder there's an export, and then there's a hash link directory, and there's the bin for hash link. So if I go in here, this was when I did a build for hashlink. This is my native Windows application, and then here is, if I back out, here's the HTML5 version, right? And instead of having an application, it's an index.html file and a corresponding JavaScript file. And what I do when I do the JavaScript build, I actually also do a post build step which copies the JavaScript files from the client export folder into the server static folder. such that it's sitting on the server, the web server, under this directory. Keeping in mind the web server is SideWinder running hacks. And so now, if I go over to the web server side of things, I'm not going to run the client from within Visual Studio. What I'm going to do is I'm going to stop the web server, which is running here. I'm going to run just Shift F5 this guy. Actually, yeah, that should work. Once I see it running over here, see it's doing a build. There, it's serving files up there. I should be able to go to my local 127. Okay, so what's happening here? This is the web server. This is running the server side of things. It's serving up static content from that directory, and as you can see, it's actually web-based, using the same interface, same user interface across both web and native applications. So let's bring this up just to show you that it's working. You go sign in. Now, you know, for the most part, everything acts exactly the same as the native application. I have noticed, for example, there's this visual glitch where these things are all lined up nicely in the native app. So I've got to track. You know, there's minor differences, but in general, everything is working exactly the same. And if you look, if you look at the network, you can see what it's doing. It's basically in the back end is hitting the web server. And the other thing is that here's the server. I can go to the project service and put a breakpoint in list service, list projects, and just refresh, and it's hit the breakpoint. Here I am. Oops, I should have put a breakpoint inside the try catch. I'm not sure why, but if I try to step into a try in Visual Studio Code in HashLink, the breakpoint has to be inside the try already. So I'm going to do it again. Refresh. And here we go. So now we're stepping into the code. You can see it basically does a database.acquire to get the database connection. There's connection pooling in SideWinder. Then it does a request against the database. It just basically does a select against the projects directory or projects table, and then loops through and builds an array. And once it's done, it does database.release, and it's done. And then that's it. So I've showed basically the fact that you have the client and the server both written in hacks. You can debug them from Visual Studio directly. Let's take a quick look at some of the features. I showed that AI tools work. I can generate hacks UI code automatically. Generate Postman collections using AI. So the server, let's try to get into some of the details of the server a little bit. So how SideWinder works is that you define your interfaces for your REST API endpoints on the web server. So like in this case, I have a iProject server, and it's got an API endpoint, which is /API/projects. And if I hit that as a GET request, a GET HTTP request, it's going to actually call the list projects function for me. So the interface defines how you access the REST endpoints and then maps those routes to the corresponding functions. So list projects, create project is a post to the same URI, passing JSON data in the body as a project, and the project looks like this. You can see there's in this case I have a models where my project has an ID, a name, a description. My environment looks like this. My machine looks like this. Each one of these map to the data that is being sent back and forth from the client to the server. And so my project service defines all of these different endpoints, and then I have an implementation of the project service. It inherits from that, or it implements that project service, and then provides bodies to each of these functions to actually do the database calls. And SideWinder as a framework has a bunch of features in it to make all this really easy. So if you define the interface and the implementation, you then can hook up the routes for it, and there's something called auto router that is part of SideWinder. That what it's doing is it actually uses a feature of Hacks called its macros, and so other languages have macros, but the really cool thing about Hacks is that the macro, you write the macros. Okay, what is a macro? A macro is code that generates code, and its purpose is to make it easy to do things exactly like what this is. And what this is this generates all of the wiring, all of the hookup that's required to make it so that when a request comes in for a particular URI, for example, if you hit /API/projects on the server, that it's going to automatically know that it should call this function, list projects. And that's an easy one because there's nothing being passed to it. But let's look at, let's say, update project. Update project has an API. It's a REST function. It says it's going to be a put to projects / and then an ID, and that ID is going to be a number. It's going to be an int that corresponds to an existing project in the database. So if you go to projects and you see like 1 is that one, 2 is this one. So the API expects you to pass an ID here, like 1, and then a project. And it automatically generates all the logic that's needed to wire that up for you. So you don't have to create a route. You don't have to check the request object and find the parameters that are being passed to it and the query string, and get the project from the request body. It generates that logic at compile time for you, and that's part of the macro functionality. So SideWinder actually does have, if you can actually see it, here is actually a custom route that isn't using that auto client functionality, and basically it has router.add, says it's going to be a post and then to this function, and then you get a request and response, and you can do things with it. You can do old school client server functionality here, right, where you're setting a response and you're setting headers and cookies and stuff like that. And for the most part, you don't have to do this though, because most of the time you just define an interface, an implementation, use auto router, hook it up. Other things that are built into SideWinder, there's dependency injection, and that's using one of the Hacks libraries. So, because one of the key things about SideWinder is I didn't want to have to pull in too many dependencies. So SideWinder is built on top of Snake Server, or fork of Snake Server. Snake Server was a real basic, and kudos to the developer. But even in its description, he says that it's a web server. It's the basic web server implementation for serving up static files. He built it based on a port of a Python example of a web server. And the reason why I'm using it is because it was a good base to start from for targeting a web server that is written entirely in hacks, rather than relying on being built on top of a container. And so I depend on Snake Server and hacks injection, and that's the dependency injection functionality, and JSON to object, and that's basically it. Not many dependencies are required. Very easy to, okay, okay. The client side, that's a different story. When you're writing a client side app, it pulls in Lime, which itself is a couple hundred megs of libraries and tools. OpenFL, which is a Flash replacement. So it's kind of like, without getting into too many details, Hacks was originally sort of one of its main reasons for existing was to replace the fact that Flash was going the way of the Dodo, was being retired, and so the Hacks is basically built to look like ActionScript, which was a programming language from Flash. So long story short, the client is bigger, but SideWinder itself is mostly the web server side, and then some sample implementations on the client. But where I was going with that is the dependency injection, which is kind of an advanced feature, but basically allows you to take an interface and map it to an implementation. That uses hacks injection. And then there's a middleware layer in SideWinder. So this is, the rest of this is all SideWinder specific. So this is built on top of Snake Server and not part of Snake Server. But basically, middleware allows you to add, as part of the pipeline, when anybody makes a request to the web server, you can add little bits of logic that run before the request executes. To allow you to do things. One of the things you might do is add an authentication middleware, which is what this is doing. This one here adds, so app.use is the middleware sort of add this piece of middleware call, and you can see here what it's doing is a logging middleware. All it does is for every request that comes in, it's going to log information about the request, and then it's going to go to the next piece of middleware in the chain. And the next piece of middleware in this case is going to check to see whether you're trying to hit one of the API routes, and if so, make sure that you're logged in. And so that's what middleware does, is it allows you to drop these pieces of functionality that run for every request. And yeah, and then like I mentioned, as far as the SideWinder logic goes, there's a cache service as well for caching data on the server. There's a logger built in that logs to an SQLite database as well as to a text file. There is a router implementation for hooking up specific routes. For example, this is an example right here, app.get hello. So if you hit /hello in the server, it's going to do this. There's also a that's pretty much it. But the big one that I haven't actually shown yet is the auto routers, or the auto client. Sorry. So on the client side, you have this client application. You got some user interface, and you want it to make calls to the back end. So you want it to call the server. And what happens is we have something called the auto client. It again is a macro well, here's the description. Macro that generates an asynchronous client for a service, annotated with get, post, put, and delete. So I think I mentioned it before, but basically in this source code I have a client and a server in the same repository, and if I didn't mention it, I have a shared repository that's shared between both of them. And that allows me to have logic and code that's actually used by both the client and the server, all both written in hacks. So the deploy models, for example, if I go into the source code and I look at deploy models, this is part of the shared project. It's used on the client and the server, and it defines, the data that's exchanged. It also defines the services. So that iProject service was actually in the shared project. So what that means is on the client over here, I can automatically generate the code necessary to make calls to the server using the interface provided here. So the project interface, if you go to it, iProject service, it says that there is an API call at /API projects, and based on that, AutoClient can create a proxy that you can then call off to the server, and you don't have to worry about HTTP requests. You don't have to worry about whether or not it's JavaScript or whether it's running as on one of the sys targets. If I haven't explained it already, sys targets, most of these are all sys targets, meaning they're compiled to run directly on that platform. But JavaScript is not. JavaScript is running within a browser, for example. So there are some slight code differences sometimes when you're dealing with JavaScript versus the sys targets, and that's all handled basically automatically. So if I go back to here, for example, the login dialog, when I do a login, when the login button is clicked, I want to make a call out to the server, and I want to pass something to it. So the login request, actually, let's go back to create project, because that's where I've been looking so far. Create project's a better example. So this AutoClient.create passing iProject service generates a project proxy, and from here I can call that project proxy. It automatically generates a function called create. The original function was called create project. This one's called create project async. It expects a project as a parameter, and then it has a callback function for both a success callback and for an error callback, kind of like Ajax when you're writing JavaScript code. So you can handle the success here and the error here, and you don't have to worry about all the logic of how to hook up how to call an HTTP request out to this thing. It's generated automatically by the AutoClient, which makes this, again, low friction. The whole point is to making it fast. I think that's pretty much it. I think I'm going to end this demo right now, but I am continuing to work on it, and I'm excited to see where it goes, and I hope that eventually someone else besides me uses it. Thank you.